All right, welcome everyone to another Sunday morning session. So today this is going to be the last lesson for term one, right? We've gone a long way. We've learned a lot this term, advanced algebra, geometry, and trigonometry. So today what we are going to do is the session is going to be split into two parts. The first part is we will finish up the last leg in the game, which is trigonometry, right? We'll do the angle of elevation and depression stuff, right? We'll do a bit of a worded problems. We'll try to apply whatever we've learned in last three-ish lessons around trigonometry. So we will do some worded problems and we'll make use of everything that we've learned, right? But yeah, so I'll keep the advanced. This is like the advanced extension year nine stuff that we're doing today. But I'll try to keep it to a point that it is makes sense to you, and I'll not go beyond that. And then the second part of the session is going to be a quiz, right? And that quiz is going to be from anything and everything that we have learned in last. Today is the 21st session, right? So 20, I mean, I will just randomly pick topics, right? And it is going to be a multiple choice quiz. And we'll see how we go, right? So I'll just quickly do a refresher before we, give each other a break towards Easter. That allows us two things. One, we rejuvenate, and second, we get more sleep on Sunday, right? We all need that. Cool. All right, let's kick off. Now, again, rule of the session, I keep repeating, no spamming on the chat. Uh, I will call out names in case someone's found spamming. First warning, the names will be called out. Second warning, second is action after warning. That means people will be pushed back to the waiting room, right? And I don't want you to miss uh, the last session of the term, right? And last but not the least, it is at the end of the day still technology. If you stop hearing me, please let me know in the chat immediately. I'll do some magic and I'll fix it up. If my internet trips off, no need to panic. Stay in the waiting room and I will rejoin the session. If I end the session, you rejoin the session. And last but not the least, if your internet trips off, don't worry, log back in. It sends me a message and I will let you back in. All right. With that, let's kick off for the last topic of the trigonometry that we are going to do today. So what we are going to do today is obviously trigonometry. But we are going to learn today is something called the angles of elevation and depression. So these are the things that we are going to learn today. Now, what have we learned so far? We have learned that there is a right angle triangle, which means one of the angles is 90 degrees and the other angles could be any two angles, right? They sum up to 90. Now, let's say this is my angle theta, and let's say this is A, B, C. So this is B. Probably we'll take a stock standard stuff, right? This is C, this is A, this is B. We learned the first thing, which was Pythagoras theorem, which tells us that C square equals to A square plus B square. We know all of that, right? Next thing that we learned was the so ka toa. Sine, cos, and tan. Sine, cos, and tan helped us before we generate these ratios, these sine theta, cos theta, and tan theta, we need to identify what is called the hypotenuse, H, that's the opposite, O, that's the adjacent. And based on that, we can calculate so, ka, tua. Sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. We know all of that, right? We went ahead and using the SOHCAHTOA, what we learned additionally was finding the unknown side. And most importantly, what we learned last week was finding the unknown angle. And how do we write unknown angle? So, come again. If I have, we still have people joining in. If we have this as theta, and let's say this is 5, and this is 6, and I'm asked to find this theta, I'll say, okay, this is hypotenuse, this is opposite, and this is adjacent. I am given opposite and adjacent. That means I can find using this as TOA, which essentially means tan theta is 5/6. I'm just recapping what we've learned. So finding the unknown angle, and I told you last time, theta is, I write tan with a raised to the power of -1, 5/6. And if you plug this into your calculator, you will get a number, and that is nothing but degrees. How do you read this? You read this as tan inverse 5/6. Tan inverse 5/6. That is how you read it. The word tan inverse, the word inverse, in fact, is very important. Sine, cos, on tan is just a ratio that you're using. So if in case you are joining this session for the first time, or you might have missed a few sessions, last 1 or 2 sessions, everything is recorded just like this session and is being shared as a YouTube playlist. All the 20 lessons learned so far, starting from September last year till today, are uploaded on YouTube as playlists, full 1 hour lessons, right? So if you have missed any sessions prior to this last year, go ahead and watch them, but watch them with a notebook and a pen in hand without calculator, right? Because that's not a YouTube video, that is a session. Okay, now let's come back to what we are going to learn today. Now, let's take an example. Let's say there's a person standing on the road, and there's a tower right in front of that person. This is the tower. Now, this person is seeing from his eyes the top of the tower here. So when he's trying to see the tower, which is obviously quite tall, standing right in front of this person, and he or she is trying to look at the top of the tower. What happens? Whenever we see anything which is above our height, what do? We lift our neck to see the things that are above our line of sight. We look up. Yes. So that is the line of sight of this person. That's the line of sight. But what is the original position of his eyes, of their eyes, was when the neck was leveled to their body. And if I draw a line of their original position of the neck, or probably their eyes, their original line of sight, this is how, if they will not lift their neck up, if they not lift their eyes up, that's their regular line of sight. I call this a regular horizontal line of sight as the horizontal. Now, when they have taken their eyes above the horizontal, that's the that's their new line of sight. That's the line of sight. Two people waiting in the meeting. Okay. When they lifted their line of sight from the horizontal, what they've made is an angle from the original line of sight, the horizontal. And now this angle is called theta. Now, if you look at it, what has happened? A right angle triangle is being created. If I just draw it like this, that's how it looks. The theta. That's how it looks. This theta, or this angle that they have made by lifting their line, their eyesight above the horizontal position, is called angle of elevation. They elevated. Elevated means that they've taken up. They've elevated their eyesight beyond the horizontal to make this angle theta. Now remember that, for now. Let's take another example. Let's say, again, there is a tower. And this person who's standing on the top of the tower. And they're trying to see, this tower is too high, so obviously they're trying to see a car. From the top of the tower to this car which is traveling on the road. What will happen when this person is standing on the tower or sitting on the tower, top of the tower, and they are just looking right in front when their line of sight is normal and they're looking forward? That's the direction of their vision. And I call this again as horizontal. And now someone just wrote, they look down. That's their line of sight. This time, the angle that their line of sight, when they have looked down, has created with the horizon, this angle is called the angle of depression. Depression means looking down. Now, one thing to be noted here is, let's say there is a person sitting in this car. There is a person as well sitting in this car. And this person is also looking at the person standing on the tower. So for this person who's sitting in the car, the horizontal line of sight still is the road on which the car is traveling. But for them, if they're looking up at the person on the top of the tower, they need to lift their neck up, elevate their eyesight, to look at the top of the tower. So that's the line of sight for this person in the car. Same line of sight which was for the person who was sitting on top of the tower looking at the person in the car. For the person in the car, this angle theta is the angle of elevation. Now, let's make a geometrical correlation of these two angles. When I have two parallel lines, I think we did that some time back. And I draw a line. What is this line called? Someone can tell me on the chat. What is this line called which cuts the two parallel lines? What do we call that? Yes, transversal. So this angle here and this angle here, if I say angle 1 and angle 1 is equal to angle 2. May I know the reason why they are equal? What angles are these? They are not corresponding rhythm. What angles are these? I'm looking at the chat. There are 41 people out there. Yes, they are alternate angles. No, they're not vertically opposite. They're alternate angles. So these two angles are equal, alternate. Now, look at what's happening here. The angle of depression and the angle of elevation. If these two horizontal line of sight are parallel for the people, one on sitting on top of the tower and one sitting in the car, and the line of sight acts as a transversal, and let's say I call this as theta 1 and theta 2. So the angle of elevation theta 1, theta 2 is equal to the angle of depression. which is theta 1. So the point I'm trying to make is that in the world of trigonometry, you've got two types of angles to deal with: angle of elevation and angle of depression, and they are equal. A lot of students make a very silly mistake, which I'm just going to point out here so that you don't do it. In the problems where I just talked about someone sitting on the top of the tower, someone sitting at the top of the tower here is trying to look at something on the ground. And I ask them, what is the angle of depression? A lot of students make a mistake. They say angle of depression is this theta, which is incorrect. A lot of students say that the angle of depression is this theta, which is incorrect as well. The angle of depression is the angle that the line of sight, that's the line of sight, Till the time I'm not asking anyone on the chat, Sonic, can you please, listen quietly? I have not asked anyone to write on the chat, right? Calling you out now. First warning. All right. So the line of sight and the horizontal. Anyone passing smileys, anyone passing any emotions on the chat will be pushed back to the waiting room. Right? You're distracting me, guys. So a lot of students say that that is the angle of depression. No. Few say that's the angle of depression. No. The angle of depression is this theta. Yes, this theta is equal to this theta. They are equal. But this is not the angle of depression, please. A lot of students make a lot of mistakes identifying the angle of depression. Angle of elevation is easy. But yes, angle of elevation and angle of depression are equal. But they need to be identified, correctly at the first. All right. Okay, with that thought, let's do a very basic worded question. Now, in the world of trigonometry, when we deal with angle of elevations and depressions, 90% of the time, we are just given a worded problem. And what we need to do is, first thing, read that and create the correct figure, diagram, whatever you want to call. And then you just apply your basic SOHCAHTOA to solve that problem. All right, I'm going to give a question to you now. What I want you to do is read that, create a diagram, a right angle triangle based on the information provided in the question. If that is correct, you can easily solve the problem. So I'm going to take a snippet of the problem, and then we will try to create all right, read this. I don't want you to solve this and give me the answer at the first place. I will give you the opportunity to do that as well. but I just want you to draw the diagram looking at the worded problem right in front of your eyes. Create a right angle triangle, put the angle in place, and put the figures. Everyone is able to see my screen? All good. Go for it. If someone's not able to see my screen, can you please, you need to log off, log in, or probably, yeah, only that's the only way to do it. And it's pretty visible. My screen is shared right in front of everyone. All right, you want to make a question a little more bigger. Can't go bigger than this, apologies. Is that better now? All right, let's create the triangle first. I've not asked the answer yet. Okay, let's create the triangle. It says that at a point 10 meters from the base of the tree. So there is a tree. There is a tree. And I have to locate a point which is 10 meters from the base. So let's say this is tree. And that's the base of the tree. 10 meters away. So let's say this is 10 meters. The angle of elevation of the top of the tree is 38 degrees. So someone's standing here looking at the top of the tree. And they are making an angle of elevation as 38 degrees. So this is 38 degrees. Angle of elevation. This base of this is their line of sight, is their horizontal. And that's their line of sight, which is making an angle of 38 degrees. And now you have all of a sudden a right angle triangle right in front of you. So what's the question? Question says, can you calculate the height of the tree? So I need to find the height. I call it as h. Now the question becomes very, very simple. You've got this as 38 degrees. This is h and this is 10. You just need to find h for me. And as we learned, I think previous session and our session before, I start identifying my h, my o, and my a based on this angle of elevation, 38 degrees. And I say, okay, what two sides can I pick up? H and a. So O and a. What ratio connects O and a? The tan. So So let's do it. Tan 38 degrees is h over 10. So eventually, what is h? H is 10 times tan 38 degrees. That is my answer. You don't need to give it to the nearest centimeters because you would need a calculator. Is this correct? Is this, do you understand this? Anyone, any doubt here? Don't worry, if you still have doubt, we'll do maybe a bit more, right? We'll do another one. All right, cool. Let's try one more. Don't worry, Arav, we'll do one more. And that'll make more sense. Okay. All right, let's try to do this one. going to take a snippet of this one now. All right, here you go. Part A tells you to draw a diagram, and part B tells you to calculate the height of the tree. Go for it, please. Now I'm after you giving me the height of the tree this time. I'll give you a minute to do that. No one waiting. 60, tan, 35. All right, let's do it. Let's do it. There's no, it can't be 42, as in I don't know what is tan 35, honestly speaking. Let's try to do this, right? It says from the point of the ground, exactly the same question, just the numbers have just changed. That's it. The point on the ground, 60 meters away, it is from the tree. So that's the tree, and that's 60. Now, the angle of elevation on the top of the tree is 35. So this is 35 degrees. I've done part A, so they want me to draw a diagram, label diagram, right? And that's the height of the tree is h. Is this label diagram clear to everyone? First thing, because if this is not clear, probably you cannot do part B at all. This has to be absolutely going into your head. If this is not clear, probably you need to go back to the basics of trigonometry and those, look at those two videos first, those 2 or 3 videos first, before you come here. Right? Okay, cool. So this is fine, right? Now I'm just asked to find the height of the tree. That's about it, right? What is the height of the tree? For this angle 35, that's my opposite and that's my adjacent. Again, Toa, tan 35 degrees equals to h over 60. So what is h? H is 60 times tan 35, or I can just type 60 tan 35. That's the height of the tree. Is this making sense, everyone? Yes? All right, good. Okay, let's now do another question. Which is the angle of depression. Okay. Let's do this. This one is a good one. And they've actually done the question that I'm going to give you now. They've actually given you a lot of information, so that'll make your life a lot easier. Don't worry, I will do one more. Angle of this will make. things more clear. Okay, this is a good question, but it's not a difficult one. Now, let's read this question, and I'm going to do this question. And then probably I'll give you a very similar question for you to try. It says that a 30-meter tall lighthouse stands on the top of the cliff, which is 180 meters high. So this is a cliff here. This is the cliff, which is 180 meters tall. And you've got another lighthouse, which is standing on top of the cliff, which is 30 meters on top of this cliff. So what is the total height from the ground to the top of the lighthouse? Is 180 plus 180 plus 30 is 210 centimeters, 210 meters. Just keep this number with you for now. Let's read ahead. Determine the angle of depression, theta. That's the angle of depression. From the top of the lighthouse to the ship, which is 3,700 meters from the bottom of the cliff. So I'm given this distance of 3,700. And now I'm asked to find this angle of depression, theta. Now let's try to make a triangle first, a cleaner triangle to sort this out. This is 210. That was the horizontal, and this is the angle that I need to find, theta. And I'm given 3,700 meters as another distance. Everyone understands this triangle that I've made of the question, yes or no? First things first. Forget about people who are giving me answers without me even asking them to do. Good. This is okay, cool. We are so far so good, right? Now, I'm asked to find this theta, but hang on. This theta or this angle is sitting outside my right angle triangle. That's my right angle triangle. This angle sits outside. But I just told you at the beginning that the angle of depression is equal to this theta, the angle of elevation, by the rule alternate angles. So if I find this theta, then I can find this theta, which is the angle of depression. So now the story becomes really easy. The story is that you have a right angle triangle. This is 210. This is 3,700. And you need to find this theta. Simple. So eventually, this is the opposite and this is the adjacent, which essentially means tan theta equals to 210 over 3,700. So what is theta? Theta is tan inverse 210 over 3,700. which is nothing but the angle of depression that we are after. Right? Is this clear, everyone? Everyone, is this clear? This is very, very simple and basic, right? We've got around 44 kids again. Yeah, is everyone clear with this? I need to see a yes from everyone just once. Because I'm going to give you a question now to solve that, right? Okay, cool. Let's do a question now. Let's do another question. Okay, let's do this. All right, question coming to you. Go for it. Don't worry about two decimal places and stuff like that. Just calculate, the distance. But in fractions as well, it is fine. Or probably in terms of angle, it is fine. I'm waiting for people to answer. The answer that I've got so far are incorrect. If you don't know, write I don't know. What ratio are we going to use here? What ratio are we going to use here? Anyone? Is it sine, cos, or tan? All right, we are going to use tan, right? Let's understand how. A lot of you don't understand this, you know. A few of you have given me right answer, but let's talk about it. It says from the top of a 50-meter high lookout. So you've got a 50-meter high lookout. So someone is sitting here at 50 meters. The angle of depression of a campsite. So someone may be at a hill and they're at the campsite. And let's say this is the campsite. That's the campsite. So the campsite is, the angle of depression is 37 degrees. So they're looking here and this angle is 37 degrees. So if this angle is 37, obviously this angle is also 37 degrees. And it says how far the camp is from the base of the lookout. So this is the lookout. And that's the base of the lookout. So what they're asking us is to find this distance. This distance, let's say this distance is x. First things first, people who did not understand in the first place, do you now understand what I have done here? Yes? Cool. Now, we just need to find x. That's about it, right? So this is opposite, and this is adjacent. Again, a TOA. See, in these kind of questions, you need to think and create the diagram on your own. You are on your own. You're not given the triangle. So TOA. And TOA is tan 37 degrees equals to opposite is 50 over x. And now what is x? X is 50 over tan 37. Does that make sense? Does that make sense, everyone? The angle of elevation and angle of depression. Good. Kinda. What is the kind of? Either you understand or you don't understand. Okay. Now with that, I have actually, from a topic standpoint, I have finished trigonometry, right? That was the last topic that you should be knowing. At this point, I mean, trigonometry goes way beyond. It is an ocean, right? And those of you who are going to take, math methods or maybe advanced maths, uh, will do a lot more trigonometry once they cross grade 9. Grade 10, 11, 12 is all trigonometry. All right, cool. Now, let us now do some random stuff, right? And we'll see how you go, right? Let me pull out something. Uh, okay. All right. Multiple choice question. Here you go. Go for it, please. C, D, C, D. Getting different answers, right? C or D? People are divided between C and D. That worries me. Okay. Let's quickly understand what this is, right? All of you, most of you are saying D. All right. Let's quickly do what this is. X minus 3x minus over 3 minus 1 equals to 4. I will first add 1 on both the sides to get rid of this 1. So now I have x over 3 equals to 5, and then eventually x is D is the right answer. Okay, let's move forward. This one looks wonderful. Let's do this one. Take your time before you give me the answer. People who were spamming were sent into the waiting room for some time. You have been allowed back into the session. Please be mindful. All right, go for it, please. Take your time before you start throwing me answers. A. A is the common theme emerging. A? I don't know. A is the right answer. Good. All right, next one. Let's try doing this one. This one's good. Here you go. Go for it, please. You're saying A. Someone said an E. Someone said a B. B. E. My very candid take on this, if this question is not right, and I clearly say it again, if this question you're not able to do it, irrespective of how much smart you are in maths, you're not going to be really successful. This is the bread and butter of basic algebra, right? So no matter how much you're scoring anywhere, if this is not right, you need to do a lot of hard work. So you need to get out of that overconfidence zone and do this rigorously, do practice rigorously. All right. Let's try to understand how we are going to do this question. D equals to square root of A over square root of B. Now, in order to get rid, I need to find A equals to something. That's my says make A a subject. Now, please don't attempt it, Arav Patel, right? And anyone else, just listen to it, right? Very important. None of you have given me the right answer, I think, except one odd here. Maybe, right? I mean, I don't know at the face of it what is the right answer, but I'm just trying to. So I think most of you said D or something. If that's the right answer, good. Let's try to do it. So I need to make A a subject. A is under a square root. So how do I get rid of a square root? I square both the sides. I square both the sides. So what happens? This becomes B square equals to A over B. Why? Because square root and square, they cancel each other. We did this long back when we were doing indices. So square root is nothing but a power of half. The power of half. Yes, I think E looks to be the right answer now. Now you can do it, right? So what is A now? A is B square. Unfortunately, 90% of you were not able to tackle this. That tells us we are not in a great position. If you're preparing for selective school exam and you're not able to handle this, please, you need to practice a lot during the Easter break, right? So that is the right answer. With that, I rest my session and term one to peace. And I really enjoyed and loved, teaching you all. And I hope you had a similar experience, looking, the similar numbers, 40, 50, plus students every Sunday morning gives me motivation to come back. And I hope you get motivation to study. So make sure that you don't take break literally. Breaks are just to refresh, rejuvenate, not to forget what you've done in the last 10 weeks. Make sure you study, and you study a lot. At least half an hour to 1 hour mathematics practice is really, really important. Right? And with that, thank you very much. And I will see you now back term two, the first Sunday. Someone's raised their hand, probably. Uh, anyone has any last thoughts? They can type it on the chat, please. No, yeah, this is our last session. All right, cool. Not a problem, Dilo. Thank you very much. You all guys have been an absolute wonderful students, with me. And I'll let you go. Thank you very much. Enjoy your Sunday and have a great break. Thank you.